Whenever you're in a modern building, you're literally surrounded by an invisible network of safety. But here's the thing. That fire protection system is only as good as the process used to build it. Today, we're going to pull back the curtain and look at the critical QA/QC documents, the super detailed paper trail that turns a simple blueprint into a life-saving promise. Let's dive in.
Right? That's the big question. A sprinkler head on the ceiling is a promise that water will be there, right when it's needed most. But for an engineer, an insurance company, or the fire marshal, a promise isn't enough. They need proof. And that proof isn't just looking at the pipes and pumps. It's a meticulously documented chain of custody, proving every single step, every material, and every test met the exact standard. And that is the paper trail we're going to unpack.
So how on earth do you manage hundreds, sometimes thousands of these documents for a single project? Well, it all starts with a digital command center. Think of this QA/QC tracker. It's usually a pretty beefy spreadsheet as the project's central nervous system. It's a live dashboard that's constantly monitoring the health of the entire quality process, from day one all the way to handover. Okay, let's take a peek inside that command center. At a single glance, the lead engineer can see absolutely everything. See that status column? That's the heartbeat of the project. Green is good to go. Yellow means we're waiting. A single pending status on a key document, like a work inspection request, can literally halt the next stage of construction. This isn't just a list. It's a dynamic tool that connects a document, like a PQP, directly to its rulebook, say NFPA 13, and puts a name next to it. It's all about accountability.
All right, so where does this whole paper trail actually begin? It starts way before the first piece of pipe ever shows up on site. First, you have to build the project's foundation by setting the rules of the game, the rules that everyone, from the main contractor to the consultant, absolutely has to follow.
And the cornerstone of that foundation is the PQP, the Project Quality Plan. Honestly, you should think of this as the project's constitution. It's the high-level document. It's not going to tell you how to tighten a specific bolt, but it clearly defines the overall quality standards we're going to follow, which NFPA codes apply to which systems, and who specifically has the authority to approve or reject work. Without a PQP, you'd have chaos. With it, everybody's playing from the exact same rulebook.
Okay, now we zoom in. If the PQP is the rule book for the whole game, then the method statement, or MS, is the detailed playbook for one specific task. It is a step-by-step guide, almost like an IKEA manual, but for highly trained professionals. It makes sure that every single technician installing sprinkler piping does it in the exact same sequence with the same tools and the same quality checks. That's how you guarantee consistency across a massive project.
So, with the rules in place, the project starts to move from paper into the real world. Now we're on an active construction site, and the documentation has to keep pace with the physical materials arriving and the actual work getting done.
And the very first gatekeeper for quality on site is the MIR, the Material Approval Request. The key phrase here is before it's ordered. Nothing gets bought, let alone installed, without an approved MIR. So, before a single valve is purchased, the contractor submits the MIR with all the technical data sheets to prove it meets the design specs. This includes those crucial UL and FM approval certificates, which are the non-negotiable stamps of quality in this industry.
And this workflow right here shows you how that paper trail protects the project. Step 1, the MIR, is the digital pre-approval on paper. But what happens when the delivery truck actually shows up? Well, that triggers Step 3, the MIR, or material inspection. The contractor is literally requesting an inspector to come down to the loading bay. That inspector then physically checks the delivered items against the approved MIR paperwork. We're talking model numbers, pressure ratings, everything. It's a perfect closed-loop system that ensures what was approved is exactly what was delivered, no exceptions.
Okay, so you've got materials coming in, you've got work happening all over the place. How does anyone keep track of what needs to be checked and when? That's the job of the ITP, the Inspection and Test Plan. This is the project's master QA/QC calendar. It schedules every single critical inspection point, from a visual check of pipe welds all the way to the final system pressure test. Without an ITP, crucial checks would absolutely get missed. It's that simple.
So, when the ITP says it's time to inspect, say, the fire pump's alignment, how does it actually happen? Well, the contractor finishes the job and then submits a WIR, a work inspection request. This is the formal, hey, come check my work, signal to the consultant. Once that consultant inspects the work and signs off on the WIR, that document becomes a permanent, auditable record that this specific task was done correctly and according to the approved method statement.
But let's be real, no project goes perfectly. It just doesn't happen.
Problems always come up. The mark of a truly professional operation isn't avoiding problems, it's having a formal, documented process for dealing with them when they do.
What if you see a problem before it happens? Let's say the blueprints show your main fire pipe running right through the same space where a giant HVAC duct is supposed to go. You don't just guess or try to work around it. You stop and you issue an RFI, a request for information. This is your proactive tool. It's a formal pause to ask for an official, documented solution. It prevents mistakes, saves a ton of money on rework, and ensures any change to the plan is formally approved by the designer.
But what if a mistake has already been made? An inspector is walking the site and discovers that the wrong temperature-rated sprinkler heads have been installed in a kitchen area. That's when an NCR, a non-conformance report, gets issued. This is the reactive tool. It does way more than just flag the error. It forces a formal investigation into why it happened, and it documents the specific, approved plan to fix it, making sure it never happens again.
So it really just boils down to this simple but absolutely critical distinction. An RFI is the question you ask to prevent a problem. An NCR is the report you file to correct a problem that already exists. One is proactive defense, the other is reactive recovery. And a well-managed project has to be great at both.
And now we get to the moment of truth. The system is built, the materials have been verified, the individual installations have been inspected, but does it all work together as a single life-saving system? It's time to prove it, and that happens in the testing and commissioning phase.
And we're not just talking about flipping an on switch here. The principles of NFPA commissioning are incredibly strict. And for good reason. You're trying to simulate the intense, brutal conditions of a real fire. The goal isn't just to see if it works, it's to generate hard, undeniable data that proves every single component performs exactly as it was designed to under maximum stress.
And this is what that proof looks like. Not just words on a page, but hard data. You've got a hydrostatic test report showing the pipes held 200 psi for 2 hours straight without a single drop in pressure. You have a performance curve that proves the fire pump delivered the exact flow and pressure it was rated for. These documents are basically the system's performance resume.
And right at the very end, just before the final sign-off, comes the QC checklist. Think of this as the final fine-tooth comb. Engineers walk the entire site with a checklist that can have hundreds of items, and they verify every last little detail. Is the clearance around each sprinkler head correct for its specific spray pattern? Is every single pipe hanger spaced according to NFPA 13? It's that final sweep to catch any tiny issue before the project is officially handed over.
And with that, we've finally reached the finish line. Every plan, every report, every test, and every correction is now complete and, most importantly, approved. The final step is to package this entire project history into one comprehensive record for the building owner and for the authorities who give that final stamp of approval.
This final record is captured in what we call the as-built drawings and closeout documents. Now, this is critical. These are not the original design plans. They are the final, definitive record of what was actually installed, including every single change that was made through an RFI along the way. For the entire life of that building, these documents become the official history that maintenance crews and future engineers will rely on.
And here it is, the final handover package in all its glory. It's a complete library of the project's entire quality story. You've got the as-builts showing the final layout, all the test reports with the performance data, the O&M manuals for future use, and the complete archive of every QA/QC record we talked about. This binder, or these digital files, are the physical delivery of the proof we asked about at the very beginning.
And all of that meticulous work, all those thousands of documents and signatures, culminates in this single critical outcome, the final approval from the authority having jurisdiction, whether that's the fire marshal or the civil defense. And this isn't just a piece of paper. It is the official, legally binding certification that the promise of safety we started with has now been verified, proven, and documented for all time. So I'll just leave you with this. The next time you're walking through an airport, an office, or a hospital, and you happen to glance up at a smoke detector or a sprinkler head, I hope you see a little more than just a piece of hardware. I hope you can now imagine that invisible chain of documents, the plans, the reports, the tests, all that proof that stands right behind it, ready to keep that silent promise of safety. Thanks for joining me.